The second rule we're going to look at today is, sorry, so going back, just kind of recap, that's the quotient of two powers. The second rule we're going to look at is the power of a quotient. All right, this rule is a little quicker, and it's kind of like the power of a product rule from yesterday, but power of a quotient works like this. If I have a divided by b to the x power, that's the same thing as just simply raising the exponent to each side of the fraction. Okay, so you end up getting a to the x divided by b to the x. All right, this is a really, really important rule for a lot of applications in finance, and kind of like figuring out like investment account values and or figuring out values like on a car when you buy it and things like that. This is a type of application of that rule that happens all the time. So here we go. Let's take a look at the actual rule. The rule says if the quotient of two different bases is raised to the same power, you can multiply the inner exponents by the outer exponent. All right, so again, what they're referencing there is the bases here are different. You have an a and a b. Those are different values. They're not like the previous rule where the bases were the same. All right, so in application here, let's say if you have something like 1/2 raised to the third power. Okay, there's two ways to think about this. You could think of it as, oh, it's 1/2 times 1/2 times 1/2. Okay, and that's what it means to cube something. But if we use the rule, okay, that would be without using the rule. If we use the rule and kind of jump over with what it says over here on the left, that means you're going to rewrite it as 1 to the third power divided by 2 to the third power. Okay, and then 1 to the third power is just equal to 1, and 2 to the third power just equals 8. So that would just end up becoming 1/8. Another example, if you have y squared over x, all of that raised to the fourth power, think of this as being like x to the first power. Okay, so when you simplify this, you're going to do y, and you're just going to multiply 4 times 2, so it's going to become y to the 8th power, divided by on the bottom, you're going to do 4 times the 1, so that's going to be x to the 4th. Okay. And the last rule here, last example for this one, we have 3 over b cubed. So again, think of this as like 3 to the first power when you're evaluating your answer. And you're going to end up rewriting this as 3 to the 4th power, because 1 times 4 is 4. All that divided by b raised to the 12th power. Okay, because you're just going to do 4 times 3. Okay, so you're doing 4 times 1, that gives you the 4. 4 times 3 gives you the 12. And then 3 to the 4th power, if you use a calculator to figure it out, that's just 81 divided by b to the 12th power. Okay, let's take a look at some examples. X to the 4th over y to the 5th. Why don't you guys try that real quick? I'll pause here and you can give it a shot. Okay, you should get x to the 8th power divided by y to the 10th power. Second example, 4c to the 10th divided by 12c to the 3rd, all of that raised to the 2nd. Holy moly, what do you do here? What I would kind of urge you here, there's a lot going on in this one, and there's a couple different ways you could handle this. I'm going to show you, I guess the first way would be to kind of recognize that, wait a minute, this is like 4 to the first power, and that's like 12 to the first power. We're going to have to do the power of a product rule and the power of a quotient rule all at once. All right, so one way you could handle this would be to just do basically distribute the 2 to all the powers on the inside here. So it would become like 4 to the 2nd power times c to the 20th power, because you're going to remember when there's parentheses you multiply the exponents. 10 times 2 is 20. On the bottom you're going to have 12 to the 2nd power. All right, all that times c to the 6th power. And then you're going to have to simplify that. All right, you're going to have 4 squared is going to be 16. All right, divided by 12 squared is 144. And then you're going to have c to the 20th and c to the 6th power. And then you're going to have to look for a common denominator between 16 and 144. What's the common denominator? And I believe 16 goes into 144 9 times. So this would be like having 16 times c to the 20th, all that divided by 16 times 9 times c to the 6th. So if I do my giant ones here, I got giant ones with the 16, they're going to go. And then the c to the 6 is, the 20 is bigger than the 6. So when you go to simplify this, you're going to end up with 20 minus 6 is 14. So you're going to get c to the 14th power. All that divided by this 9 that's going to be left on the bottom. All right, so it'll be c to the 14th divided by 9. Okay, let me just erase some of that because I'm going to show you the second way. Kind of do the same thing. All right, a way that you could also do that, and this is actually the way I would probably advocate that you do, because I just, my own personal preference, it's a little easier. Another way you can handle this one is if you notice when you start the question, like, oh, we can simplify the inside. We can do the inside part first. Like, let's just handle this first because I can clean that up. If you have 4 over 12, that reduces to 1/3. 4/12 is 1/3. And then if I look and see c to the 10th, that's bigger than 3. So I can rewrite that and multiply that as like 1 times c to the 7th power. Okay, so just kind of cleaning up that inside. Remember that's the inside of the parentheses and the whole thing's being squared. If you rewrite this, it just becomes c to the 7th power divided by 3. Okay, and now since that's all going to be squared, you're going to end up with c to the 14th power, okay, because 2 times 7 is 14. And then remember, this is 3 to the 1st power, so you're going to do 2 times 1. So that's going to become all that divided by 3 to the 2nd power. Okay, and then c to the 14th is just going to be c to the 14th, nothing's going to change there, but then 3 squared is 9. So you still get the same answer that we had in the previous example. All right, c to the 14th divided by 9. Okay, let me erase that just for a second and just make this a little cleaner. Okay, but c to the 14th over 9 will be your final answer there. Okay, so let's just write that. C to the 14th divided by 9. All right, one more example here. Again, kind of looks terrifying, but just like the previous example, simplify the inside first. The first thing I'm looking at right away is, oh wait, I got a 5, that's top heavy for the x's. 5 minus 3 is 2, so I know I'm going to have x squared on top. And then I look at the y's and I realize, ooh, 7's bigger than 6, so y is going to end up on the bottom. 7 minus 6 is 1, so I have y to the 1st, and now that's all raised to the 5th power. Whoops, not that. Okay, that's all raised to the 5th power. So when we go to clean this up, we're just going to multiply 5 times 2, and this is y to the 1st, so you're going to do 5 times 1. So you're going to get x to the 10th power, because 5 times 2 is 10, and then 5 times 1 is 5, so you're going to get y to the 5th power. All right. All right, so here's an example from Delta Math that you might see. So, all right, you got this 14 x to the 5th, y to the 5th over 35, x to the 6th, y to the 3rd, kind of summarizing the rules here. Let's break it down to pieces. You've got the 14 and the 35. You got the x to the 5th and the x to the 6th, and then y to the 5th divided by y to the 3rd. All right, and let's just kind of start examining now what's going on. So 14 and 35, the greatest common factor of those two numbers is 7. So I can rewrite 14 as 2 times 7. All that divided by 35, which is 5 times 7. And then you have the x to the 5th and x to the, whoops, I'll fix that, hang on. You got x to the 5th. Okay, all that divided by x to the 6th. And then you have y to the 5th divided by y to the 3rd. All right, so when you go to examine what's happening here now, I have giant ones with the 7s. They're going to go. Okay, so you're going to be left with 2 and then the 5. And now look at the x's. 6 is bigger than 5, so I'm going to do 6 minus 5 is 1, so I get x on the bottom to the 1st power. And then the y's, 5 is bigger than 3, so I'm going to do 5 minus 3 is 2, so I'm going to have 2y to the 2nd power. So your final answer here, just kind of cleaning things up, would be 2y squared, all that divided by 5x. That would be your final clean answer there. All right. Same thing, when you have to type your answer in Desmos, make sure you use that computer keypad to help you get your solution.